Welcome to Inside Builder channel, Python experts, programming enthusiasts, and my dear friends. We are on the way to help machines to solve their own problems. That is the objective of this series of videos. And in this video, we are going to see object-oriented magic. We are going to make two robots to chat through object-oriented code. You see these two robots? This is R1 and this is R2. As the robots complete their tasks, they have to talk with each other. So how are we going to do that? That's going to be our discussion. We are going to use objects. In the last discussions, we have already seen how we can use object oriented and why we are using object oriented, etc. We evolved the machines from functional paradigm to object oriented paradigm, and we saw how to why to and what of object oriented. We are going to move a little further in this video, and we are going to continue using turtle, and we are going to give it additional methods or additional abilities so that the objects can talk with each other. So what I mean that the objects can talk with each other and how can they do it? Because at the end of the day, if there is an object and this object contains some kind of data and some kind of abilities, knowing what the other object also has in terms of data, in terms of ability, is very, very important. Assume that there are two robots that we already showed to you, and these robots have to first of all connect with each other. That is the first step a robot can do before it starts to communicate, right? Assume that you have your mobile phone, and if you want to communicate with your router, first thing is you will have to connect through your Wi-Fi, and then only you will be able to start getting the internet, correct? The same way the robot have to connect with each other. So that is the first step, and that's going to be a method that we have to attach it to the robot. Second, we are going to make R1 to complete a couple of tasks, and R2 also going to complete its tasks. And next, we want R1 to find the center of R2. So this is one of the important steps where R1 is going to interact with R2. Right, and how we are going to enable it, that's what we are going to see in this discussion. Once R1 finds the center, then R1 moves to R2's center. All the long, after R2 completes this task, R2 waits. It doesn't do anything, even though the same kind of ability R2 also has, but R2 does not do anything. And finally, we see that R1 moves to R2 and the program ends. Let me show this in action. So this is the code that we will be executing. I'll be explaining the code after some time, but let me execute this code to begin with the demo first. Once the demo is through, then we will see how we can, how the actual connection between the stuff works. So you see the code is executing, and it is asking me to press enter to start. So I'm going to press enter. And the moment I press enter, what is going to happen is the turtle is going to form, and you'll see that it is creating the rectangles, and the turtle one which was here moved from here to here. So both the turtles T1 and T2 created two rectangles, and the T1 turtle moved from its center to T2's center. And all these things happened without any human intervention. These robots had worked on its own, and the job that it completed was to just create a rectangle. Let me again redo this, and I'm going to start. You see the rectangle is getting created, and then the entire process completes. So the R1 robot completed its rectangle, and then it moved to the R2 center. So what exactly happens here? How these things how the robots are talking with each other and how they are communicating with each other. So that's what we are going to see next. If you guys have been following my earlier videos, take a look at that. You'll actually find that I have created a new rectangle object, and in this case the rectangle object is going to contain various kinds of inputs, like its center, the length, breadth, the name, and also importantly there is an additional variable or attribute called as connected with. So this connected with is a list. If you have seen my earlier videos on list and dictionaries, the data structures, that is a primitive data structure in Python, you will understand that lists and dicts are very, very important. It can be used in lots of places to solve the problems. So I'm using a list here. The RectangleBP object is going to be just an example right now. So I'm going to show the connectivity between the rectangles using a text based output, and then I will show how this happens in the turtle. So this RectangleBP object is going to just create rectangle methods, and then inside the rectangle methods you see there is connect with and there is get other center. So these are the two methods that is going to enable the rectangle objects to connect and also to get the center of other. So the key point here is that I can send the other object and I can make it to become part of the current object. So the other object is going to come from outside and it is going to connect using this particular variable. It is going to become the part of the current object. In case of object oriented, the current object is called as self. The current object is called as self, and anything that is going to come from outside is called as other. Let us go to a code example. You will see that I have created 4 rectangles here. These are of type object rectangle BP. You see that there are 4, and then I am using this particular method. I am saying rec1, rec1, this particular rectangle variable has to connect with rec2, so this particular rectangle variable, and then I am telling rec1 to get other center, and I am giving the center of rec2. So what happens is, let me execute the code and you will see it in action. So once I execute the code, you will see that rec1 is connected with rec2. So this is an output that is provided, and also it tells what is the center of rec2 right now. So both of these things are provided here. This idea of connecting the rectangles like this is possible because of this method. The connect with method first of all takes the other object and it checks whether the other object is of type rectangle BP. So this is the first thing. If it is not a rectangle BP object, then it will not be able to connect. It will simply say that it's not rectangle, cannot connect. That output will come. However, if it is a rectangle BP object, then it will append that rectangle object to the list, and also at the same time the current object will also get appended to the connected with list of the other object. So this particular initialization is called the blueprint, as I already told you, and this particular variable is going to be the glue between multiple objects. This concept of using list as a glue between multiple objects is very, very important when it comes to various data structures like linked list, queues, stacks, and so on. Most of the graph-based algorithms also implement some kind of list or some kind of this kind glue data structures inside the init method. So this is how it is getting done. Once the connect with is completed, after that we can get the center of the other object. So when I am going to try and get the center of other object, what is going to happen is, it is first of all going to check whether the other rectangle is part of or whether it is already connected with the current rectangle. That is the first thing. If it is connected, then it will get the data. But if it is not connected, then it will respond that it is not connected, cannot get the center. Let me show you it in action. So you see that I have connected rec1 with rec2, but I have not connected rec1 with rec3. So if I use get center, get other center, and if I use rec3, you will see that it will actually print out that it cannot get the other center. So you will see that it is executing, and you will see not connected cannot get other center. So this is happening because the rect3 is not connected. So that's why this particular print statement is getting printed. And looking at the object oriented programming in this way makes it very important and easy to visualize that how we can make objects to communicate with each other. Now I have shown you an example with a simple text-based output, but in real case, when there are going to be turtles, the real robots getting involved, the same kind of idea still holds good. I am going to still use the rectangle turtle. This is a rectangle turtle object, and I am going to have names, and I am going to have length, breadth, x coordinate, y coordinate, etc. But I am not going to check whether they are connected here, right? But here I am primarily going to say that get the center. So if I am going to ask for get center from any of the rectangle turtle objects, it will provide its center. It will not check anything. It will just provide the centers. And then if I tell the current object to connect with the other object. So you see that this is the other object. So this other object has to be a rectangle turtle object, or else it will create an error. You understand why, right? If I have to connect with the other object, first of all, I need to get the center of the other object. So first of all, I need to get my center, and I need to get the other center also. If the other object is not a rectangle turtle, then this get center method will not be available. So it will throw an error. Now you guys must be intuitively understanding why when you are running some Python scripts, you get this error that this particular method is not part of this object, or this particular attribute is not part of this particular object. This is happening because inside the object that whatever you are sending is not the type that the particular script is expecting. After this, you see that once we got both the centers, then we can use simple goto, and we can make the turtle to move to the other center. So this is what happens. Currently, we have seen how the entire process of making robots to work with each other and make it to talk. Literally, we are going to make the robots talk with each other, and also use some logic to make the robots talk with each other in a sensible fashion has been completed. And all these things were done using object-oriented code. You see, as we start progressing in the ideas of making the machines to learn, to problem solve, the amount of information that I need to share, or the amount of new concept that we need to learn starts reducing. You can see from the video length itself. The earlier videos were minimum 25 minutes long, but now this is going to be just 14 minutes long. So I believe that you have learned a lot, and there is a lot to practice. The code will be shared with you guys in the description below. So do take a look, and if you have any questions, do leave a comment and provide me the feedback. Do subscribe to my channel for further updates on similar kind of videos. Till the next video, have a great time and start making the objects to talk with each other. This is going to be fun, guys, and have a great time having fun. See you guys.